I'm first going to quickly explain just what exactly is ICPC, which is the International Collegiate Programming Contest. So it's a competitive programming competition. I say more on that later. If you don't know much about it, we have example problems, but essentially it's just solving problems in time conditions, where a large part of the problem solving is coming up with an algorithm to solve the problem. And then once you have an algorithm to solve the problem, you can then code it up. Feel free to ask questions or whatever throughout this. Kind of want to make this as interactive as possible. So teams of up to 3 people, generally you would have a full team, although you don't need. But one interesting feature of ICPC is that it's just one computer or one keyboard. Obviously online, it's a bit more difficult, but they have it's like one person typing. During the competitions, probably the last years, they had some sort of virtual desktop to ensure one person works at a time, which means you spend most of the time not at a computer, reading problems, working on paper, or helping someone else code, than you do actually coding yourself. The competitions are usually 5 hours, although it varies. So ICPC is 5 hours. Many other competitions are much shorter, in the order of 2 hours. That's it for very basic ICPC. So it's an international competition, but it's broken up into regions. So here's just a map. We are in the Asia Pacific region, but within that, there's also the South Pacific region, kind of in the Asia Pacific, which is Australia, New Zealand, Fiji. So that's the region we're in. So when we're doing the competition that's coming up in October is just Australia, New Zealand, and Fiji, with most teams coming from Australia. So some useful links, I'll put these in the chat as well. The first one is to the South Pacific regional website. Second one is the South Pacific Facebook group. That's different to the Facebook group that you would have seen in the email. This one is the Facebook group for the competitions. So they announce things about competitions and that sort of thing in that Facebook group. So dates, how to register is all announced via that Facebook group. So it's useful to join them. So you may have seen the emails, but there's what's called a divisionals contest on the October 16th. That's the first round of ICPC. And that's open to anyone in uni. So teams of up to 3 for that. So registration for that is actually coming up. So early bird registration, if you do that, you get a free shirt. That's actually due this coming Monday. I think there's an email saying how to register. Let me know if you have any issues with that. Open to anyone in their first 5 years of uni. Thanks, Dallas. All registration closes September 30th. So if you register after September 20th, but before the 30th, you don't get a free shirt, but otherwise you can do it. So as I say, you can use the Zoom chat here or the CPM SOC Discord to find a team. We have a team funding channel, which people use if you are not sure who to team with. It's good to not do it on your own because it's a lot more challenging on your own. It's good to have teammates to work with. So either with some friends or you can meet people via Discord or whatever. So how the process works is you've got divisionals. Approximately the top 12 teams qualify for the next round. There are some more rules, like I think it's at most 2 per university teams, and they sometimes admit more teams depending on conditions. But approximately 12 teams will then qualify for the next round. That's on December 11th. Again, likely to be done online, obviously COVID. And from there, teams qualify for the World Finals, which location date unknown, some point next year probably. But no one really knows. The World Finals is kind of all messed up because of COVID. There's still a backlog of 2 World Finals that haven't happened yet. But that's the general format. So how many teams qualify depends on the region. So generally it's 2 teams from our region that qualify. Although I think it can vary from year to year depending on the allowance. So 12 teams qualify to go to the finals. So everyone can do the divisionals. 12 teams qualify to the first finals, and then more teams qualify for world finals. Obviously, You don't have to be going for this. Like making finals and making world finals is very competitive. You can do divisionals just for fun. Yeah, so Dale said there'll be 2 teams this year going to world finals, but you can do it just for fun. Useful to help you with interview practice because the questions are often similar to those you might find in coding interviews. Help you with just general coding skills, coding under time pressure, and just for fun. Finally, there's what's known as Anzac rounds. These are just practice rounds. There's generally, I think there were 7 this year, somewhere on the order of 5 to 10 per year. There's one more coming up on 2nd of October. Again, if you join this Facebook group, they'll post more details about that sort of thing. And the website also has details about Anzac rounds. These are generally consist of problems from past regionals, past divisionals, or contests from other countries. So they're very similar to what you might expect to see in divisionals. So as Dallas said, the number of teams that qualify for world finals depends on the strength of your region. We normally get 2. There was one year where we got 3 because our region did particularly well, but normally 2 teams qualify for world finals. At most 1 team per university. Yeah, so I think last year UNSW teams came 1st and 2nd in the finals, but unfortunately only 1 team can make it to world finals, which is a bit of a shame. UNSW tends to do quite well. Usually the top performing team in Australia, which is cool. Finally, languages. So you can use C, C++, Java, or Python in most contests. Some of them might allow a few more languages, but in general, in all these competitions, these 4 languages are definitely allowed. Generally, C++ is most commonly used. If you just know C, that's fine too. C plus a few extra features is all you really need. If you know Java and you like that from, I don't know, 2511, feel free. And if you know Python, also you're free to use that as well. In code demonstrations today, I'll be using C or C++, but I'll be using essentially C when I'm demonstrating some code later. Finally, there are past problems. I'm going to put this link in the chat. You do have to register for an account to view these, but they have past problems from our region. It's not complete, but they have a lot of problems, especially from recent years. And you can also submit to them, which is very nice. Finally, a quick note about uni courses. So you need to be able to program to do ICPC. That is perhaps a given. So doing 1511 or an equivalent knowledge is kind of essential to be able to do these contests. You need basic programming skills is what I mean by this here. Other uni courses, so Comp 2521, which some of you here have done, some of you here haven't done. Some of you, is it run this term? If it is, some of you might even be doing it right now. That is useful. It will help with some questions. It's not required for every question. The questions vary quite a lot. So some of them do not require knowledge from 2521. In quite a few of them, knowledge will help. Then 3121 is also useful for harder problems. So some of the algorithms taught there will help in a lot of the harder problems. Although the problems are more about problem solving, so they might use a technique, but generally it's more about solving the problem. So most problems don't require advanced technique, but there are some which might require techniques which are covered in that course. Finally, if you do enjoy competitive programming, certainly recommend taking Comp 4128, which is programming challenges. It runs in term 3. Obviously a bit biased because I do tutor that course, but I certainly recommend doing that course at some point in your degree if this is what you're interested in. It's certainly not an easy course, but is quite a fun one and will put you in good stead. That'll give you kind of all the theory you need to do ICPC. Any of the questions. From there, it's just essentially any of the questions. Yeah. The last thing here is that in these workshops, we'll explain new algorithms techniques when required. So although doing these courses is very useful, in these workshops, we're not, because most of you do not have much experience, we're definitely not assuming knowledge in these areas. It certainly will be helpful when doing ICPC, but you should be able to follow along in these workshops. I mean, you have to be able to program, but apart from that, you should be able to follow along in these workshops without having done, especially the harder subjects. Are there any questions about kind of the logistics of ICPC and particularly about the coming up round, which is coming up, well, in about a month? Yes, you are. So these workshops, no commitment. Obviously our goal is to get you ready to do those, but there's no commitment. Discord link again. Yes, can someone put that in the chat? Thanks. There's no commitment. You can, again, you have to come to every workshop. If you come to like every second one, then that's fine as well. Obviously, the more workshops you come to, the better, but each one is kind of self-contained because in each workshop, we'll look at problems. So if you don't go to the previous workshop, you're gonna come to the next one, that'll be okay. We'll record some aspects of them. Like some of this first part will be recorded. When you do like group work, that probably won't be recorded, but some parts will. So you said you finished degree last term. So you can't do ICPC itself. Unfortunately, that's only open for uni students. However, there are a world of other contests. So if you're interested, so things like Code Forces is one website that runs weekly contests. At Coder is another one. Not PY, what am I doing? It's not Python file. That's the one. JP, Japanese website. They run like weekly contests if you're interested. Companies like Google and Facebook run like yearly multi-round contests. So Google CodeJam is run by Google annually, and Google Kickstart are like off-round problems, kind of like how ANZAC is off-round for ICPC, Kickstart is off-round for CodeJam. They also, I think, do some amount of recruiting or like from those sort of things. I'm not sure how that works, but they do say they do some sort of recruiting from Kickstart. I think you can like be invited to do an interview or something if you do well in Kickstart. Yep, and you're welcome to look at other. Yep, so Kaggle and plenty of other websites. Yeah, there are plenty of other competition options for you guys to look at if you have graduated uni. Yeah. And so the other one, the first one is Facebook Hacker Cup. This is, yep. As Dallas said, if you want to be completely sure whether you're eligible or not, check those rules. But I believe if you've graduated uni, you will not be eligible unless recent graduates are, but just check the rules to be sure. So what we're going to do is we're going to look at some example problems, probably two. So the first one is a fairly easy problem. So the problems vary. Some of the problems are kind of like some of the easy ones especially are more implementation. So it's more like given a thing, can you code it? And the harder ones are kind of more about theory. So we're going to look at one problem that's more of like implementation. They more tell you what to do and you code it up without much kind of too much algorithmic thought behind it. And then we'll look at a slightly harder problem. So the first one is just essentially you're comparing dates using the Australian format compared to the American one. Don't worry too much about the backlog. Basically, the question is they give you a date. So they give you a date and you have to report whether it's a valid date in your output, whether it's a valid date in month, day, year form, whether it's a valid date, whether they're valid dates in either, or they're valid dates in day, month, year. Pretty much just which format they're valid dates in out of which format you have to consider. In kind of every possible ordering. So you get given a list of dates and you have to report which different date format it's in. So these ones are in month, day, year. It's your only possible one because, well, if you look at it, this number here is bigger than 30, which means the last one must be a year. Otherwise, that's invalid. Finally, this middle one here is bigger than 12. So this one must be days. And then this first one here, then must be months. So that's all that's left. In this first example, you output unsure. because these in fact could be in any format. This could be in day, day, month, month, year, year. Could be in month, month, day, day, year, year. Could be in any format. Could be in year, year, day, day, month. Like we don't know from the first one what format it's in. And then we have this one, which is not valid in any format, because this one here means this third one must be years. But then both of these ones contain numbers bigger than 12. So these ones can't be months. So none of these ones are valid to be months because they all have numbers bigger than 12 in them. And then this third one must be year, year, day, day, month, month, and etc. Does the question make sense? I think so. I don't think it's too complicated. So the input format is just the number of dates you're given. You're given all the dates and you have to output the format. So this problem is more of a how do you code it up question, although there is some thought given to how to do it. So does anyone have any, like a brief overview of how we might go about solving this problem? Split the input lines? Yep. So we want to consider each input line separately. Take the max of all three. So the thought was take the biggest value here, and biggest value here. So the first approach, which was take the maximum value on each of these rows, that's what I was doing when solving this problem. One issue of that, though, is it becomes complicated when looking at, because some months have 30 days, but some have 31. So if the maximum value is 31, you then have to check what month the 31 comes from to see whether it's valid or not. And then you also got leap years to consider and that sort of thing. But another approach was to just store which ones are possible and then kind of mark all of them as invalid if they're not. Store every possible arrangement and delete the ones that don't work. Yes, so how I would do it is, we could write a function that takes in three numbers, a day, a month, and a year, and returns whether that day, month, year is valid or not. That can be the first thing that we do. And so if we can check whether day, month, year is valid, we can then, there are 6 combinations. So for each date, we can try all of the 6 combinations and then record what ones are invalid. And this kind of leads to code that is fairly nice and not badly written. So if I share my screen now, what I mean is we can write a function called like a Boolean function is valid. It takes in the day, the month, and the year. And then we can just check if a day, month, and a year is valid. So first of all, so the day has to be between, how do we check this? First of all, the day must be, if the day is less than 1, like the day, we kind of, there's no 0th day. What doesn't, so we return false if day is less than 1. That's the first check, like that. Then how do you check if the day is valid? Well, which months have 31 days? So if the month it is 1, or what month? 5th month, 31 days, January, March. Yeah, odd numbers, right? It's all odd numbers, right? Except then it becomes weird, right? Around middle of the year. Month equals 5. So it's not the nicest thing. We have like but we're just considering every month that has 31 days. In this case, we want to return whether the day is less than or equal to 31. Note that every possible year is valid. The year doesn't matter. If the library is in there by default, you're free to use it. So yeah, In Python, you can use dates on library thing. If that's a default library, you're fine to use that. Yeah, so it does speed your time up. I'm just going to quickly code this one up. Yeah, but I've already checked days less than one here, so that's all good. Here. Yep. Finally, if the month is February, then in this case, I'll only check for leap year because leap year does have some weird conditions for multiples of 100, but this problem just says to only consider multiples of 4. So if the year is a multiple of 4, then we want to return the day is up to 29. Otherwise, we just return non-leap year, days up to 28. Finally, the month has to be, well, what are the remaining month? If the month is less than 1 or the month is bigger than 12, again, we have an illegal month. Finally, if none of these conditions are true, that means the month must be an odd number, even number month that isn't February, at which point we just want to check if the day is less than or equal to 30. So we're correct in that a dates on library would work to do this function here. But either way, we have this other method of doing it, just a quick function that returns whether the day, month, year is valid or not. It's a bit of a, that's another point that Dallas makes. Because leap years in this case, they don't consider multiples of 100 correctly for leap years. It's possible that a built-in library might, because for example, the year 2100 is not a leap year, as an example. Although if you assume the year was in the 2000, I think it should work. Because obviously 2000 was a leap year because of leap year weirdness. So that's our function here. So for header files, we're going to use this in C++ is the same as including stdio.h in C, because C++ is like C with a few more things. Don't worry about the red squiggle here. I've not got around to fixing VS Code yet, but it does work fine, trust me. And we're going to store whether each of the 6 cases is valid. So we're going to keep a format valid. And for now, I'm going to number the formats. We're going to say, just for simplicity, let's say format 0 corresponds to this one. Format 1 is this one. Format 2 is what's left. We have day, day, year, year, month, month. 3 is day, day, month, is day, month, month. I'm probably doing them in a weird order, but that's okay. 4 we can say is year, year, day, day, month, month. And then 5 will be year, year, month, month, day, day. So I've just numbered all the formats to keep track of them nicely. And initially, we're going to just fill them all as being true. So a nice function C++ has, which is in the algorithm header, is we can just use a nice function called fill, and we just go fill. Yes, the recording will be available. It'll be on the CPM-SOC website. Can someone post the link to that? Thanks. So here we're just filling, is format valid with true? So for now, we're going to initially say every format is valid initially. And then as we go through, we'll mark formats as invalid. So let's scan in N, the number of dates. And then we'll go through dates one at a time. To scan in the date, I'm pretty sure if my knowledge of scanf is correct. So we're going to have day, month. We'll just have ABC. I think we can just scan in like this. We'll scan in the 3 numbers, the day, month, and the year. And then this is where it becomes a bit annoying. We're just going to check all 6 of these combinations off. So the first one is if the ordering is day, month, year. So if not is so function was is valid. If not is valid, A, B, C. So if this is not the case, then that means that this format doesn't work. So if that's the case, then we're going to mark is valid, format valid, 0 is false. So we're going to say if day, month, year is invalid, then mark it as being invalid. Finally, we have month, day, year. So we just swap these around and we check format 1. Finally, we're going to go, the next one is for day, year, month. So to do that, that means B is the year, because middle one's a year. A is, so this will be, this correspond to this, that's 2. Please correct me if I made a mistake here. This is a little bit annoying. Finally, for month, day, year, this means month is B because the second one. Year is, wait, what have I done? Month is A, year is C. I think I've made a mistake. BCA, thank you. Let me think about this. Yes. That means the day is, it's C, A, B, because C means the day is in position 3, the month is in position, the day is C, the month is B, the year is C. Yeah, next permutation works too. At some point we do have to hard code this to this, right? Because at some point we have to output the answer. So next permutation will probably make my life a bit easier, but I'm just doing it this way because this. But yes, I could probably make it a bit nicer with next permutation. Sorry about that. But again, day is B, month is C, year is A. And the last one, which is we have C, A, and then B here. And if all of them are unique, then I haven't made a mistake. Yep, seems fine. Yes, I could use next permutation. I have to be smart because I have to permute this and this together. So I think you could, if you permuted this and this together. In fact, I think it would work. But this works too. But yes, next permutation does work. You have to be careful though to permute the dates and the ABC together. But I actually think it would just work. I'm just have been a little bit not smart in coding this up. Thank you. Yeah, good point by Jonathan. Like in a program context, still it works. This is a bit annoying, but again, if you have 3 teammates to all, like if all 3 of your teammates look over this and check it's right, it might take like a few minutes, but it's probably worthwhile. Okay, finally, our final check is there a valid format? If there's 1 valid format, we print that. If there's 2 valid formats, we print just, we print unsure. And if there's more than, and it says no valid formats, we print invalid. So let's just go num valid formats and loop through. So this just is adding, this just, because remember a Boolean is 0, false, 1 if true. This will count number of valid formats. And if number of valid formats is 0, then we're going to print impossible. If the number of valid formats is bigger than 1, we print unsure. And my recommendation is, as I've done, you copy and paste these from the problem statement. Don't type them yourself because you don't want to make a typo impossible and get the problem wrong because of it. It does happen sometimes. Finally, if there's 1 valid format, then it becomes a bit annoying, but in fact, I can just copy these. I'm just going to literally just copy what I've written here and just go, if the first format is valid, we're going to print this. Again, it's not the nicest way of doing it, but it gets the job done, as Jonathan said. If you're coding an assignment, you probably don't want to do this, but thanks. I'll add the new line at the end. In fact, new line is not strictly required, but I do like putting new lines in. So thanks for letting me know. So generally, when problems are judged, a new line at the end is not required. In fact, normally they ignore excess white space, but it is convention to put new lines at the end because it can make reading the output easier. So I should have put that in before. But yes, in fact, I can just print the new line at the very end to make my life easier. Like that. Thank you. Yes. So this code is done. Again, next permutation could work, but this also works too. And no, it didn't take me very long to code this up, despite it being a bit annoying. I spent maybe 10 minutes on it. I wasn't timing. Anyway, let's compile our code. Some useful compile flags that give you warnings are Boolean Wextra and give us some extra warnings in our code. Similar to what, like, I think DCC gives you heaps of warnings. It might be using similar flags, so they like similar warnings to what these flags give you. And then we compile our code like this. Our code compiles. Let's run it on the first sample input, which is, doesn't want to copy and paste for me, so I'll just type it out. 03. Now it's typing out, I think. There we go. That followed by this. So our code should output unsure. It's actually outputting impossible, which is interesting. So our code's doing something wrong. So let's just print out do some debugging here. So it's checking correctly 1, 2, 3, and 2, 4, 1. But then what's it doing wrong? Let's just do you set the value of n? I scan n in here. What do you mean by set the value of n? Oh, should be 6 here, right? My bad. Yes. So I'm filling in the array at the start wrong. I should be filling the first 6 things. So fill in is valid all the way up to 6. Thank you for that. So just inserting my variables wrong. And now it outputs unsure, which is what we want. The second case, there we go. The answer to this one should be month, day, year. We get month, day, year. This third case should be impossible. It gets impossible. This fourth case should be month, year, day. So we should get month, year, day. We do. Finally, we should get year, day, month. All right, so we pass. In an actual contest, you would then submit the code and it would tell you correct or not. In the interest of time, I'm not going to submit this, but hopefully, let's just hope it works. But in actual contest, you would submit it and get feedback. All that matters is code correctness. So you're not marked based on your code style, just whether it gets a question right or wrong. And you have to get every test case right to pass the points. So if we fail just one test case, we don't get the points. But in ICPC, they will tell us in the contest if that happens. So we have time to debug. Just so the question is there a reason to use it in file rather than just copying into the terminal? Just that it makes my life easier, because copying the terminal, if you have to run it multiple times or if you want to make small changes, like changes to an 04, it's usually easier to use it in file, but there is no absolute reason why you would have to. It's just easy. Which version C++? Each contest will say it will certainly be at least C++ 11. I can check the South Pacific Regional website now if they say. I'm not sure if they do or not. But I'm not sure. Yeah, probably check a bit later, but it'll be at least C++ 11, perhaps 17 or 14 or 17. But somewhere on the website it will say, but it certainly varies based on contest to contest. The judge will normally say what one you're using, but I'm not sure exactly off the top of my head. I can check back on that after this if you're still interested, but if someone else knows, please let me know. Okay. Any good resource for C++? So website like learncpp.com, I think is, if I remember your URL correctly, although the C++ required for competitive programming is more like C plus more features rather than more complete set of C++ knowledge, like the object-oriented side of it, which you might learn in courses like there's a C++ course at UNSW. Don't know the code number. So you can look at Learn TPP and look at just like go through the early stages of it. Important things are like data structures. Yeah. So things are like so some header files are useful to learn. So algorithm has heaps of things like how to sort, things like that. Other useful things are vectors, maps, set. So there are like queue, stack, priority queue. These things come to mind. So if you want to like write those down, and so for those who can't, because I don't think you can see the chat in the recording, I said algorithm, vector, map, set, queue, stack, priority queue. These are all things that are in the standard library in C++. My recommendation is just look those up and kind of have a read of how they work, because they will help you a lot. Things like classes and that sort of thing, you don't need for competitive programming. And for things like ICPC, C, so C++ being just like knowledge of C plus some other standard libraries is all you need. Like here I used fill, for example, that's in algorithm. Otherwise, this code is otherwise like perfectly valid C. Except I think bools, you have to hash include them in C. But otherwise, this is more or less perfectly valid C. So C will do you pretty well, but as Jonathan said, some more data structures is all you really need. Okay, I'm going to look at one more problem before we split into groups. Where is, so I've got Learn CVP here, which just has some resources as well if you're interested. What's the link that Dallas sent? This link here? Oh, CVP reference. Yeah. This link here links it. So this is the reference they give you for ICPC. Regional, sorry, yeah. This one also has quite a bit of useful stuff. So if you click here, for example, on vector, it gives you like how to use vector. Is there an algorithm header here? Algorithm library, for example, you can look up like somewhere down here will be fills here, for example, and other functions. Anyway, the second problem we'll look at today is, I'll scroll down a bit, is these are all from one Read Divisional, I think 2018 Divisional, is dubious recordings. Feel free to have a look, although often the first paragraph of the problem isn't particularly useful. So you can just ignore this whole first paragraph in the case of this problem to speed us up. So starting from here, this is all you need to read to understand the problem. So you have a recording that's a sequence of samples. So you just have a sequence of integers. So as an example, you can have 1, 2, 3. And then you consider every possible range. So all the ranges are, so there's ranges of size 1. Those are the values on their own. So we have 3 ranges of size 1. There are then 2 ranges of size 2. That's this and this. And 1 range of size 3. That's the whole thing. Each range, we can sum the values in that range. So the ranges of size 1, they have sums 1, 2, and 3 respectively, because the ranges of size 1, their sum is just the one element. The range consisting of the first 2 elements has a sum 3. The range consisting of the last 2 elements has a sum 5. And the range consisting of all 3 elements has a sum 6. The question is, what is the average sum across all the ranges? So if we add these together, we get 6, 9, we get 20. So in total, there are 20 divided by 6 is the average, which is 10 divided by 3. And the problem wants you to output it as a reduced fraction. So they want you to output 10 over 3 like this. Which is a bit of a weird output format, but That is what it is. In another case, for example, if you're given the input 2, 5, 1, then the ranges will be the individual ranges. They sum to this. The first two values, which sum to 7, the last two values, which sum to 6, and all three values, which sum to 8. If we add all these numbers together, this is an 8 if you can't read my handwriting, you add these numbers together, you get 2 plus 5 plus 1 plus 7 plus 6 plus 8, you get 29. So the answer then would be 29 divided by 6 is the average sum of the ranges. In the first sample input, there's just one range with sum 5, so you get 5 divided by 1. Does that make sense? Okay. Let's put in here for, yeah, so that is what the problem's asking of us. Now, the thing is that the very simple solution is just to add up every range individually. The problem is with n up to 200,000, there's going to be approximately 200,000 squared ranges. In fact, what is the exact number of ranges? For a given n, what's a formula we can use to compute the exact number of ranges? Any thoughts? Well, how I would do that, no clue. Well, that's fair. So factorial, it's going to be in the range of n squared, triangular. So how I would look at it is, let's first consider ranges. It's n plus n minus 1 plus n minus 2, etc. That's, yep, because there are n ranges of size 1. There are n minus 1 ranges of size 2. There are n minus 2 ranges of size 3, etc. So the total number of ranges then will be n plus n minus 1 plus n minus 2. We can just probably just try Googling this to go as a formula, like n plus n minus 1 plus n minus 2. And you'll get probably formula. Is there a, or triangular numbers? Triangular number. Like you could just Google it. I think Google is allowed in, no, Google is not allowed in ICPC, but in training we can use it. A nice, you get that formula here. A nice way to derive it though, how I would derive it, how I would derive this is to go, well, let's consider points where the start and end is different. That's n choose 2. So the start and end are different values. Then there are n starting points. There are n minus 1 ending points. And this covers every range twice, because this will consider ranges. This will consider each range. It'll count it, like if we have 4 things, it'll count the range starting at 2, ending at 4, and also the range starting at 4, ending at 2. So we divide by 2, and that gives us the number of ranges where the start and end are different. This is n choose 2. But then we can add n to this to get all the ranges which are of length 1. If you compute this, you'll get the exact same formula. You can, this is just n plus 1 on 2. These are the same things. So in practice you can Google, but yeah, in ICPC you can't Google. In some contexts you can, but this is like n choose 2, this is math knowledge. I think 1081 or something might cover things like this, but sometimes some basic combinatorics is needed. N choose 2 plus n. But in fact, one thing to work out is, notice the formula is n plus n minus 1 plus n minus 2. Your program can compute this number manually, because like you can just write a for loop to compute this for you if you wanted to. Yes, but there is a formula for it, or you could compute it using a for loop. There are many ways of doing it. Now, the point I'm getting at is this number is very large for n equals 200,000. I can just do the calculation now. 200,000 times 200,001 divided by 2. We get 20,000 100. We get this number here. This is a very large number, like 20 billion. We cannot, in the 2-second time limit, we cannot do that. We can do approximately 100 million operations in a second on a decent speed computer. There is no way we're adding every range together in this time. So we need a faster algorithm than just adding every range separately. So we want to work out the average. To work out the average, we need two things. We need the total sum and the number. We already have the number of ranges. We just worked that out. We have a formula for that. It's just n plus 1 on 2, or equivalently n plus n minus 1, etc. Then, if we compute that number, what's an efficient way to compute the total sum of every range? Any thoughts on how we can do that efficiently without considering every range independently? This is where the trick of this problem comes in. It's how can we work out the total sum of every range without doing it the simple way, because the simple way is too slow. It'll take too long and will time out. A rolling sum. What do you mean by a rolling sum? Let me think. Yeah, all good. You have time. I'll give you a few minutes to think about it. It's not a simple problem. So I'll give everyone 2 minutes to think about it. In fact, no. I'll give you all a minute to think about it and type in the chat any ideas, and I'll explore those ideas at the end of the minute. So from now, I'll just be quiet for a minute. All right, that's been the minute as promised. So we had two ideas. So the first one was we want to calculate the number of times a number is added towards a sum. That's a good idea. So what we could do is we calculate how many times this one appears in a sum in a range, how many times 2 appears in a range, and how many times 3 appears in a range. And then we multiply those numbers and add them together. And the second thought was, I believe all numbers are part of n arrays. Well, a good way to see if that's true or false, well, we can test it out on this sample input. So let's look at this sample input, the 1, 2, 3. And let's write out all the ranges. In fact, the ranges are, there is just 1, there is just 2, there is just 3, there is 1 and 2, there is 2 and 3, and there is 1, 2, and 3. So how many times does each value appear in a range? So how many ranges does 1 appear in? 4. 4? You sure about that? It's 3. Yep. How many ranges does 2 appear in? it's 4, and 3 appears in 3 ranges. So the overall sum is then 1 times 3 plus 2 times 4 plus 3 times 3, and you get 20 again, as we got before. So we get the same answer we got before. Now, unfortunately, this kind of debunks the idea that everything appears in n ranges, because this 2 here appears in 4 ranges, not 3. Okay. So what Dallas said, ranges are uniquely identified by the start and ending point. So the number of ranges an element appears in is the elements to the left times the elements to the right. That is correct. So think about this 1 here. This 1 appears in every range that starts at 1 and every range that ends at 1 or after 1. So there's 1 starting point and 3 ending points. So it appears in 3 ranges. What about 2? Well, 2 starts in it appears in every range that starts with a 1 or a 2 and ends with a 2 or a 3. So it appears in 2 times 2 is equal to 4 ranges. And 3 is the same as 1 by symmetry. If we had 4 numbers instead, like 1, 2, 3, 4, then the 1, for example, would appear in 4 ranges. Every range that starts at 1. Two, on the other hand, how many ranges does 2 appear in? Well, 2 appears in every range that starts with 1 or 2 and ends with 2, 3, or 4. So in this instance, 2 would appear in 2 times 3 is equal to 6 ranges. And so if we zero index these numbers here, then each number and index I appears in I plus 1, which is just how many numbers appear at or before it, multiplied by n minus I. This formula here is just precisely what I was saying, what Dallas said, which is the number of elements to the left, including yourself, and the number of elements to the right, including yourself. Because the number of ranges it can appear in is just the number of starting points times number of ending points, because every start and end point is 1 range. So does it make sense then that this number is the number of ranges that element I appears in? I think, yeah. Yep. And so the overall sum, if I want to use some maths notation, the overall sum then is just like the sum of I equals 0 through like the n minus 1. It's just of like AI. This is let's call AI the ith thing in the array. So array I multiplied by I plus 1 n minus I. So, and you can do, and like this is pretty simple. Like a for loop can compute this. That's that's very simple to. It's just a very simple for loop can compute this sum, and that's order n. This is 2018 divisionals. So you may well, were you in that contest? Well, this is 2019, maybe. Yep. Okay. This is order n. Okay. So we have the total sum, and we have the number of ranges. The very last thing, and perhaps the final trick, is the problem requires us to simplify the fraction. We have to simplify 20 on 6 through to 10 on 3. And I think someone mentioned this before, but one way we can simplify this sum down is using what's called GCD. If you haven't done a maths course like 1081 or something, you might not understand this. I'm not going to go through the maths of it too much because that's a long topic, but it's just the greatest common divisor, which is just, it's school maths, yeah. Highest common factor. I think it probably is school maths, right? Yeah. 1081 covers how to compute it, but I think you cover it in school. It's also known as highest common factor. So the GCD of 20 and 6 is just it's 2, because the highest common factor is 2. So then you divide both numbers by 2 and you get 10 on 3. Yeah. So I'm pretty sure in theory you learn this in like primary school, but then you kind of forget about it until like uni. But yes. In fact, C++ has a built-in function, which is in C++ 17 or later, which computes GCD for you, which is quite nice. Also an algorithm called Euclid's algorithm, which you're free to Google in your own time. To show how easy it is, I'm going to very quickly code this up because it will take me like about not very long at all to show just how easy it is to code up. We're going to include algorithm. I'm not sure what header file GCD is in. Can someone GCD? I'll look at GCD C++ to look at what header file it is in. You can look at document in a contest. You can look at documentation. It's in numeric. It's in bits. Yeah, so it's in this header file. I'm not using bits just because it doesn't work on everyone's computer. But it's in numeric. And in a contest, you can't Google it, but you can look at the documentation and you should be able to find it in not too long. But you can use bits as well So if you don't know, this header file here hash includes everything, but it doesn't work on every computer. By default, it doesn't work on Mac, for example. So that's why I'm not including it. But then we're going to use long longs. So a trick to save us time, we can do type def long long LL. This just means we can type LL instead of long long. Remember, long longs can store values up to 10 to the 18, which you need for this problem to not overflow an int. So we're going to have n and the array, which is n is up to 200,000. So we just scan in n. We're going to scan in the n numbers. We then compute our sum. So that's just a formula we calculated before. So if we go using long longs to avoid overflow, the formula was, we calculated before, it's just AI times I plus 1 times n minus I. That is just the formula we calculated. Then the number of ranges, a different formula was n plus 1 times n divided by 2. Make sure it like that. Again, and then we can just, we get the GCD. So we get the GCD, which is a default function in numeric of sum and num ranges. And we're just going to print out fraction, which is just the sum divided by the GCD and the num ranges divided by the GCD. And this code, if I compile it, we need to use C++ 17. That we have to use namespace std. So in C++, you can either put like std what before standard functions, or if you use namespace std, you can avoid doing that. So okay, now our code works. And let's just run it on. So sample input we had. This was the first sample input we had was just 3, 1, 2, 3. Our code gets 10 on 3. Second sample input was 1 and 5. Our code should output 5 on 1. Finally, there was this case which was not this case. The case was just 2, 5, 1. The answer was 26 on 9. And we get 29 on 6, sorry. And so our code passes these sample cases. Again, in a contest, we would submit it, but in the interest of time, we're not going to. So yeah, this is a problem. This is a harder problem. So it's an example of a problem where most of the work is done on paper, and then coding it up is like a 5-minute operation once you've worked out on paper. Problems vary from this first problem here was mostly coding it up. This second problem here was mostly working it out. Problems normally strike a balance between them. As you get harder, the working it out becomes a lot more of the problem. For easier problems, the coding it up is much more of the problem, as a general rule. There are some problems that are hard to think of and hard to code up. those are the worst sort of problems. But yeah. Are there any more questions? Otherwise, we're going to move to the second part of this workshop, which is some more individual work where you guys will get a chance to actually do stuff yourself. If there aren't, I'm going to stop the recording